Determinants. In this chapter, first we have to learn Introduction to Determinants. Let the two equations ax plus b is equal to 0 and cx plus d is equal to 0, where a is not equal to 0, comma c is not equal to 0, means coefficients of x are non-zero. B satisfied by the same value, that is, these two equations have common solutions, then these equations are called consistent. Now the equation ax plus b is equal to 0 implies x is equal to minus b upon a, and the equation cx plus d is equal to 0 implies x is equal to minus d upon c. Thus, from these two equations we got two different values of x. Therefore, equating the values of x, we get minus b upon a is equal to minus d upon c. Cancelling minus sign from both the sides, we get b upon a is equal to d upon c. By cross multiplying, we get b into c is equal to a into d, which implies AD minus BC is equal to 0. This expression AD minus BC is called eliminant for the equation AX plus B is equal to 0 and CX plus D is equal to 0. This eliminant AD minus BC can be written in the form as between two vertical lines A, B, C, D, where first column contains coefficient of x and second column contains constant terms of the given two equations. This expression is called determinant of order 2, and the value of this determinant is AD minus BC. For better understanding, take a pause here and write down all these points in your notebook. In this topic, we have to learn determinant of order 2, means determinant which contains 2 rows and 2 columns of total 4 numbers. An arrangement of 4 numbers in 2 horizontal and 2 vertical lines enclosed between 2 vertical bars is called determinant of second order. For example, here 4 numbers A1, B1, A2 and B2 are enclosed in 2 vertical bars. In this case, first 2 numbers A1, B1 are in first horizontal line known as first row or R1. Other 2 numbers A2 and B2 are in second horizontal line known as second row or R2. Similarly, the numbers A1 and A2 are in first vertical line known as first column or C1, and numbers B1, and B2 are lying in second vertical line known as second column or C2. In this determinant, the numbers A1 and B2 lying in one diagonal known as principal diagonal. The numbers A2 and B1 are lying in second diagonal is known as secondary diagonal. Now we have to learn how to find the value of determinant. In the determinant of order 2, the value of determinant is the difference between the product of the numbers in principal diagonal and the product of the numbers in secondary diagonals. That is, in this case it is A1 B2 minus A2 B1. For better understanding, take a pause here and write down all these points in your notebook. Exercise 1.1. These problems are depend on the determinant of second order. इस एक्सरसाइज के सारे प्रॉब्लम्स यहाँ पे प्रॉपर एक्सप्लेनेशन के साथ सॉल्व करके दिए हैं, लेकिन फिर भी मेरा सजेशन है कि स्टूडेंट्स अपने नोटबुक में इसे फिर से सॉल्व करें. Now we have to learn determinant of order 3. Means determinant which contains 3 rows and 3 columns of total 9 numbers. An arrangement of 9 numbers in 3 horizontal and 3 vertical lines enclosed between 2 vertical bars is called determinant of third order or determinant of order 3. For example, consider this arrangement of 9 numbers A1, B1, C1, A2, B2, C2 and A3, B3, C3 enclosed between 2 vertical bars. 3 elements A1, B1, C1 are in horizontal line known as first row R1. Next, 3 elements A2, B2, C2 are in second row known as R2, and last 3 elements A3, B3, C3 are in third row known as R3. Similarly, elements A1, A2, A3 are in first column known as C1. Next, B1, B2 and B3 are in second column known as C2, and last 3 elements C1, C2, C3 are in third column known as C3. 3 elements A1, B2 and C3 are in diagonal known as principal diagonal, and the elements A3, B2 and C1 are in second diagonal known as secondary diagonal. For better understanding, take a pause here and write down all these points in your notebook. Now we have to learn about minor and cofactor of an element of third order determinant. The minor of an element of the determinant is a determinant obtained by deleting the row and column of that same element. Mij is the minor of an element Aij of the determinant A of order 3 by deleting that particular ith row and jth column of that element. In this case, order of Mij is 2 by 2. For example, consider a determinant A of order 3. Its every element is represented by Aij. Now see arrangement of elements of determinant A. In this arrangement of determinant A, A11, small letter A11 represents the element in first row and first column. Second, A12 represents the element in first row and second column. A13 represents the element in first row and third column. Same way in second row. A21 represents the element in second row and first column. A22 represents the element in second row and second column, and similarly other elements represented here. Now we have to learn how to find minor of the element of determinant. For example, here first we have to find minor of A11 and then minor of A32. Minor of A11 is denoted by symbol M11, capital M11. Minor M11 is the minor of element which is at the first row and first column. So by deleting first row and first column, the remaining part is the minor M11. This minor M11 contains 4 elements: A22, A23, A32 and A33, means determinant of order 2. The value of minor M11 is the value of its determinant and is equal to A22 into A33 minus A23 into A32. Next example is minor M32. M32 is the minor of element A32. So to find out its value, we have to delete third row and second column. Therefore, minor M32 contains 4 elements: A11, A13, A21, A23. Therefore, value of this minor M32 is A11, A23 minus A13, A21. Now we have to learn cofactor of the element. Cofactor of the element Aij is denoted by the symbol capital A, Ij, and this cofactor is the sign minor of Aij, element Aij, and is determined by the rule Aij, capital Aij is equal to minus 1 raised to I plus j into minor Mij. In easy words, we can say that cofactor of an element is same as its minor, only change is of sign. Sign of cofactor is depend on number of row and column. If sum of number of row and column of that element is even, then sign of cofactor is positive, and if sum of number of row and column of that element is odd, then sign of cofactor is negative. Means this sign of cofactor is depend on minus 1 raised to I plus j, where I is the number of row, j is the number of column, and if I plus j is even, then its sign is positive. If I plus j is odd, then its sign is negative. For example, cofactor A11, capital A11 is the cofactor of the element A, small letter A11, and its value is equal to minus 1 raised to 1 plus 1, means value of I is 1, value of j is also 1, first row, first column, so minus 1 raised to 1 plus 1 into minor M11. Since minus 1 raised to 1 plus 1 means minus 1 raised to 2, minus 1 raised to 2 even power means positive sign, so its value is equal to positive M11. Same way, second example, cofactor A32, capital A32 is the cofactor of element A32, small a32, and its value is equal to minus 1 raised to 3 plus 2, third column, third row and second column, so 3 plus 2, third row and second column, so minus 1 raised to 3 plus 2 means minus 1 raised to 5, odd power, so minus sign, so minus minor 32. For better understanding, take a pause here and write down all these points in your notebook. Now we have to learn how to find the value of determinant of order 3. The value of a determinant can be written in terms of any one row or any one column. Here we have to find the value of this determinant in terms of first row. Consider a third order determinant A1, B1, C1, A2, B2, C2, A3, B3, C3. Value of this determinant is equal to A1, first element of first row, into its cofactor, that is minus 1 raised to 1 plus 1, first row, first column, into its minor M11, plus B1, second element of first row, into its cofactor, that is minus 1 raised to 1 plus 2, first row, second column, into its minor M12, plus C1, third element of first row, into its cofactor, that is minus 1 raised to 1 plus 3, first row plus third column, into its minor M13, is equal to, in the first term, the factor minus 1 raised to 1 plus 1, that is minus 1 raised to 2, become positive. Therefore, the first term is positive A1 into value of its minor M11, that is determinant B2, C2, B3, C3. In the second term, the factor minus 1 raised to 1 plus 2, that is minus 1 raised to 3, become negative. Therefore, second term is minus B1 into its minor M12, which is determinant A2, C2, A3, C3. In the third term, the factor minus 1 raised to 1 plus 3, that is minus 1 raised to 4, become positive. So third term is positive plus C1 into its minor M13, that is determinant A2, B2, A3, B3. Therefore, its value become A1 into value of its minor B2 C3 minus B3 C2 minus B1 into its minor A2 C3 minus A3 C2 plus C1 into its minor A2 B3 minus A3 B2. For example, one determinant is given with elements 2, 5, 7, 3, 2, 8, 6, 4, 1. Value of this determinant is equal to 2, which is the first element in first row, into its cofactor, its minor 2, 8, 4, 1 minus 5, second element of first row, into its minor 3, 8, 6, 1 plus 7, third element of first row, into its minor 3, 2, 6, 4 is equal to 2 into value of its minor 2 into 1 minus 4 into 8 minus 5 into value of its minor 3 into 1 minus 6 into 8 plus 7 into value of its minor 3 into 4 minus 6 into 2 is equal to, solving this above step, we get 165. For better understanding, take a pause here and write down all these points in your notebook. Now we have to learn Cramer's rule for two equations in two variables. Cramer's rule for two equations in two variables. Let the two equations in two variables be a1x plus b1y is equal to c1. a1x plus b1y is equal to c1, and a2x plus b2y is equal to c2. a2x plus b2y is equal to c2. Then we can find the value of two variables x and y as x is equal to dx upon d, and y is equal to dy upon d, where d is equal to a1 b1 a2 b2, a determinant of coefficients of x and y. In this determinant D, the first row a1 b1 are coefficients of x and y of the first equation, and the second row a2 b2 are the coefficients of same variables x and y of the second equations. Or vertically we can say the first column a1 a2 are the coefficients of variable x of these two equations, and the second column b1 b2 are the coefficients of variable y of same two equations. Now see the another determinant, dx is equal to c1 b1 c2 b2, a determinant obtained from the above determinant D on replacing its first column a1 a2 by c1 c2 constant terms of the above two equations. Similarly, dy is equal to a1 c1 a2 c2, a determinant obtained from the same above determinant D on replacing its second column b1 b2 by c1 c2 constant terms of the above two equations. Thus, using these three determinants d, dx and dy, we can find the values of variables x and y of the given two equations by the formula x is equal to dx upon d and y is equal to dy upon d. For better understanding, take a pause here and write down all these points in your notebook. Now we have to learn Cramer's rule for three equations in three variables. Let the three equations in three variables be a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3. Then we can find the values of three variables of these equations as x is equal to dx upon d, y is equal to dy upon d, and is equal to dz upon d, where determinant d, which is the denominator in solution of each variable, is equal to determinant in which first row is a1 b1 c1. These are coefficients of x, y and z of the first equation. Second row is a2 b2 c2, coefficients of second equation, and third row is a3, b3, c3, coefficients of xyz of third equation. This is a determinant of coefficients of x, y and z of the above three equations. Determinant dx is equal to determinant obtained from the above determinant d on replacing first column a1, a2, a3 by d1, d2, d3 constant terms of the above three equations. dy is equal to determinant obtained from the same above determinant d on replacing second column b1, b2, b3 by constant terms d1, d2, d3, remaining columns as it is. dz is equal to determinant obtained by the same above determinant d on replacing third column c1, c2, c3 by the constants d1, d2, d3. For better understanding, take a pause here and write down all these points in your notebook.